Hello champions. Okay, so this is chapter 1, ratio and proportion, indices and logarithms, unit 3, indices, part 2. We are on page 1.18, example 4. Let us try to solve this example. Okay, so an equation is given. We have to simplify and substitute a equals to 4. Let us simplify it first. We will first multiply all the constant and keep it aside. Okay, so we have 2 into 6, 12. Okay, so it is 12 into a raised to half plus 2 by 3 plus minus 7 by 3. The denominator negative will become plus in the numerator, plus 5 by 3 and minus 3 divided by 2 whole divided by 9. Okay, so the constants 3 3s are 3 4s are. Okay, now let us solve this index. So the constants 1 minus 3, this one and this last one. Okay, so 1 minus 3, so let's just solve it. 4 into a raised to 1 minus 3 minus 2. Minus 2 divided by 2 is minus 1. Okay, we have minus 1 and this 2 minus 7 is minus 5. Minus 5 plus 5 is 0. So it is 0. So what do we have? Okay, so we have 4 divided by 3 into a and a equals to 4. So 4 divided by 3 into 4, which is equals to 1 divided by 3. Let us check the answer. Correct. I hope you understood. You just have to simplify the indexes. Let's move ahead. Law 3. Okay. So what does law 3 tells you? A raised to m bracket whole raised to n. So it says a is a raised to m into n. Okay. So when do you add? So I have few more questions now. When will you add m and n? A raised to m plus n. When do you do this one? When you have a raised to m into a raised to n. This is law 1. Like when there are same two bases with different and or same powers and are multiplied to each other. Okay, same basis and they may or may not have same powers. Okay, so what if there are different bases with same powers? For example, we are taking this one. Okay, the law, first law. Okay, if we have different bases and same powers, so a raised to m into b raised to m, is there any law for this? Yes, we have law number 4. This will become a into b whole raised to m. This is law 4. We are going to study further. Right now we are studying law number 3 and this is law 3. Correct? Okay. So I have more questions. What if there are different bases with same powers and are divided to each other? Just a minute, I will write it. Okay. So what if we have different bases? Okay. A and B. Okay, and same powers, a raised to m and b raised to n. These are divided to each other. Is there any law for this? No rule. There is no law for this kind of equation. Why? Since if a power n divided by b power n, okay, same powers, I'm sorry, I have written here m, okay, it has to be if a power n divided by b power n is equals to a power n into b power minus n, correct? When we take it to the numerator, there is no simplification for the same. For example, let us see directly with an example. 3 square divided by 2 square. Okay, so what do we have? Right, 9 divided by 4. So can you simplify this? You cannot simplify. Just a minute. Okay, yes, I'm back. So you cannot simplify this any further. Okay, so there is no such law for same powers and different bases when you divide it, but you have law for same powers but different bases when they are multiplied to each other. This becomes a into b whole raised to n. This is law 4. So with every possibilities, I have explained that some addition, some division, some subtraction or multiplication does not have any rule, since it cannot be simplified any further, but the ones which can be simplified have been incorporated as rules of indices, laws of indices that we are studying. Okay, and let us see more permutations and combinations. So there is no question of different bases with different power, because for example, if I write here uh, this one, a raised to m, okay, so if I write here a raised to m divided by b raised to n, so different bases, different power divided or multiplied to each other, both, neither this have any simplification nor this one over here has any simplification. Okay, I hope you can understand this with equations itself, and I don't have to go with explaining it with some examples. Okay, so another question: what if same bases with different powers divided to each other? A power m divided by a power n. We already have studied this rule as a power m minus n. This is law second. However, in the exam, you don't have to remember the law numbers. You just have to know how will you solve the indices or equations. Okay, so we have this law. So what if same bases with different power added to each other? Same bases, different power added to each other. No such rule. Okay, and same bases, different power subtracted. We have already seen there is no such rule. Okay, so when do you multiply m and n in power? When are you multiplying m and n in power? Having one base with power whole raised to another power, right? One base with a power whole raised to another power, right? If both are positive or negative integers, multiplication is positive. Both has to be positive, since multiplication of two positives is positives. multiplication of two negatives is also positive, and if one of the power is negative integer and another is positive, then the multiplication is negative power. So let's see the proof and explanations with assumptions and verify the law with its numerical value. So let's expand this with whatever knowledge we have. What does a raised to m means? a into a into a, m times, right? Or maybe directly let's open the last bracket. A raised to m, a raised to m, a raised to m, n times. Here we will write n times, okay? Correct? N times, correct? And what does a raised to m means? Multiplying a, m times here, correct? Okay. And these are multiplied n times, right? So what exactly is happening? You are multiplying m times into n times, correct? There are two factors. Hence, a power m whole power n is equals to a power m into n. Okay, so following above, let's see. Following above, just a minute. Okay, so following above, a power m whole power n. So we are substituting n by p divided by q, and they are positive. So what will you how will you simplify? So a power m into p divided by q, simple. And then if there is any common factors, you can just subtract it. So what do you get? So you get a power mp divided by q. Now in this equation you have now the qth power of a power m is, so qth power. Okay, so for example, we have already seen a whole raised to 1 divided by n. This is nth power of a. Now what do we have here is a m into p divided by q. So it is qth power of a power m into p, right? So this is how you are going to read. So now the qth power is whole raised to q. So if there is another bracket, you are going to again open the brackets and multiply the powers. So you will get q and q cut. So a raised to, sorry, here, this one, a raised to mp. Okay. And if we take the qth root of the above, we get, that's what we have already seen, a mp, a raised to mp divided by q, that is qth root of a raised to mp. Let's see with the help of numerical value and verify this law. For example, 2 power 4 whole power 3. What do we have with the help of law? 4 into 3. So which is equals to 2 into 2 raised to 12. What was 2 raised to 12? We have 4096. Okay. So let us see, simplify this in another forms so that we get this. Let's prove this. So 2 power 4 is 16, and 16 whole power cube, correct? So what do we have? 16 cube is 4096. Please use your calculators. You just don't have to memorize the multiplication. Use calculators and write your answer in the comment section. Let's move ahead with law 4. I've already explained you that different bases, same power if we divide it. Okay, right? So, sorry, different bases but same power we are going to multiply. Division, there is no rule. A power n into b power n we have as ab raised to n. I have written ba whole raised to n. So what if a equals to b? A equals to b. We have 2b raised to n. Okay, so what do we have? A into a power n, like if we substitute a, so a square a power 2n, right? A power 2n. This is law 3. Okay, law 3. Let's see example over here given. For example, 6 cube is equals to 2 into 3 whole cube. So what is 2 cube? 8, and 3 cube we have 27, right? So 8 into 27, what do we have? 8 into 27, we have 216. And what is 6 cube? 6 cube is 216, correct? So hence prove that even if you open this bracket or simplify the 6, the base, you will still get the answer, right? Okay, let's just directly get into example 5. These simplifications are useful how to solve the equations given in the questions. So directly we'll get right into the example 5, which is very simple. Let's simplify. Wherever there is minus, just write it in the denominator. Okay, so and powers multiply it immediately. So we have x power 3a divided by y power 3b into y power 2 minus 2a. Okay, so we are going to just directly divide it. It's better that we divide this. Hold on. Okay, so again, x power 3a, and everything is in denominator. So y power 3b into x power 3a into y power 2a. So x power 3a, we cancel it out and we have, what do we have? 1 divided by y power 3b into y power 2a, and this we are going to add, which is equals to 1 divided by y power 3b plus 2a. Let's check the answer. Correct. Okay, let's see example 6. Simplify the equations. It is a good question. Okay, let's see. Sixth root means how are you going to write 1/6? So it is whole raised to 1/6. Let's directly simplify. A power 4b divided by 6, correct? And a power in the next equation, we are going to directly divide it since it is minus b. So a power minus 2 divided by 3b, okay, and multiply, okay, x 6 by 6, okay, so this is 1, and divided, and x here is minus b into x, minus 1 into minus b is plus b. Okay, so let's take this in the numerator. So a power 4b divided by 6 plus 2b divided by 3. Okay, so let's simplify the a power first. So into 2, we have 4b, 4b and 6b and 6. Okay, so we have a power 2 into 4b divided by 6, which is 4b divided by 3, since we have two same variables, and x is 1 plus b. So simple is a power 4b divided by 3 into x whole raised to 1 plus b. Let me check if I have written it correctly. Okay. Hold on. I'm missing something. Okay, just a minute. So x power 1 plus b we have written. Okay, so the negative part, since we took the negative part to the numerator, we have to subtract it. I forgot to subtract and hence I have done it twice. So let me write it again for you. Please pay attention. A power, let's write everything in the numerator itself. Okay, a power 4b divided by 6 and minus 2b divided by 3 into x power 6 by 6 plus 1b. Okay, so this becomes 1. Okay, here we are going to multiply by 2 and this is 0. So a power 0 is 1, correct? A power 0 is 1 into x 1 plus 1b. I hope you got this one. Okay, correct. Example number 7. So if base is equal on both sides of the equation, then power is also equal. This is another normal rule, right? So if bases are equal in both sides of the equation, then power is also equal. Simple as that. Okay, so you have to find x. We have an equation. So x power 1 into x power half is equals to x power x into x power x by 2. So we have bases are same and let's simplify. Okay, we have 1 plus 1 by 2 is equals to x plus x by 2. We have x is equals to 1. Let's check correct. So in the exam, you should be able to solve the questions as quickly as possible, since you don't have to write a written paper. Let's see, example 8. Find the value of k. Again, okay, so we have just with the basic observation, you can see the bases are in the power of 3. You can make 9 also in the power of 3 so that we can equate the indexes. Let's write 9 also as the power of 3. So what do we have? 3 square whole raised to 1 by 2 whole raised to minus 7, correct? Into 3 whole raised to minus 5 by 2, which is equals to 3 whole raised to k. We are going to multiply the powers and directly add it, since here is also multiplication. Let's equate. Here this is 2 and 2 cancel. So we have minus 7. So we have minus 7 plus minus 5 by 2 is equals to k. So we have k is equals to minus 14 minus 5 divided by 2, which is equals to minus 19 divided by 2. Let's check. Absolutely correct. Okay, so important motivation or note over here is just be confident in your answer even if you get any negative fractions. Okay, let's quickly summarize this chapter and start with our exercise. So we know that a power m. Okay, so I think once we start solving the problems, the laws will become easy for you, and all the laws will come together in one question. If bases you multiply, you have to add the powers, correct? If, okay, so here I think, right, and if you substitute n as minus n, you can directly subtract. Okay, here there should be division. They have written it incorrectly. Okay, if a power m whole power n, then you have to multiply the powers, right? A power 0 is 1. Okay, a power minus m is 1 by a power m. Okay, and 1 by a power minus m is a power m. So if a power x is equals to a power y, then the indexes are equal, x is equals to y. Similarly, if the powers are same, if x power a is equals to y power a, then x is equals to y, correct? So mth root of a is a power 1 by m. Okay, some examples are given. Let's start with the exercise. First question. So 4, so it is in minus, correct? So 4, hold on. 4 divided by x1 by 4. This is how you're going to write. So option number C, okay. It was very simple. Second question. Cube root of 8 is 2. Next question. 32 is which power of 2? It is fifth power. I have already told you to revise and remember some powers, some cubes, squares and equations. Okay. Now is the time you're going to apply everything. Okay. So 2 into 2 power 1 into 2 power 5 into 1 by 5. So 5 cut. So what do we have? 2 into 2, that is 4. Option number C. Question 4. Again, same thing. 2 power 2. Okay. Divided by 2 power 5 divided by 5. So this is 4 divided by 2, which is 2. Option number B. Fifth. Again, same thing. Cube root of 8 and 27 is 2 by 3. Option number A. Okay. Sixth. What is 256? Is eighth root of 2 is 256? What, which root of, it's not root, like, okay, so which power of 2 is 256? I want you to answer this. Please answer this question. So it is 8th. Okay, hold on. 2 into 2 power 8 into minus 1 by 8. So 8 cancel, and this is plus 1 minus 1 cancel. So it is 2 power 0, which is equals to 1. Okay, it is very simple. Option A. 7. 2 power half into 2 power 2 into 3 by 4. Okay, so 2 ones are 2 twos are, and now you're going to add it. So 2 power 1 by 2 plus 3 by 2, which is 2 power 4 by 2 is 2 square, which is equals to 4, which is a positive integer. Okay, that's the second answer. B option, right? Now question number 8. Okay, so 81. 81. Is 81 the fourth root of 3, 1, correct, right? So how are you going to simplify it? So 3 power 4 divided by 4 into x power 4 divided by 4 into y power 8 divided by 4. So this is 1, this is 1. So 3x y square. Do we have any option? Okay, then it is none of these, right? Next, question number 9. Simplify. Okay, so x power a minus b plus b minus c plus c minus a. Let's cancel. Correct. So x power 0 is equals to 1. Option B. 10th. Anything raised to 0 is again 1. Option number C. Okay. 11th question. Okay. Be careful. Okay. So let's see. 3 power, let's multiply. 3 power 6 into 4 power 6 into 5 power 6 divided by 3 power 6 into 4 power 6 into 5 power 6 is the same thing, which is equals to 1. Option number D. 12th, which one of the following is true? Anything raised to 0 is 1, so it has to be equal to. Correct. So option number C. Question number 13. If all the powers, the equations given are equal. Okay. All right. This is important. Please pay attention. Okay. So suppose x power 1 by p is equals to y power 1 by q is equals to z power 1 by r is equals to k. So what is x? Okay, so let's just see this one and this one. Okay, simple. Let's simplify. So x power 1 by p is equals to k. So when the powers are inverse over here, on the other side of the equation you will multiply it. It's just the same way we do for normal bases. Like for example, when we do a by b is equals to c by d, we multiply b here on the other side and divide c here on the other side, correct? So same way p is going to multiply in the power, and let me prove you x power 1 by p is equals to k. So we are going to multiply p in the power. Here p and p cut, and here x is equals to k power p. Similarly, x is equals to, sorry, x is equals to k power p, y is equals to k power q, and z is equals to k power r. And multiplying all these, you get equals to 1. So you're going to multiply k power p into k power q into k power r is equals to 1. So what do you get on the left hand side? LHS equals to k power p plus q plus r, which is equals to 1 RHS. 1 means 1 power 1. So you have same bases and powers are also, sorry, 1 means anything raised to 0 is 1. So what do you have? P plus q plus r is 0. Okay, you have to be very careful since k is not equals to 1. It is not given. K is not equals to 1. So if all of the left hand side is equals to 1, that means something raised to 0 is equals to 1, and that is p plus q plus r is equals to 0. Okay, I hope you understood this one. Let's see Question number 14. Okay, simplify. It's going to be very simple. Okay, y whole power a minus b minus c plus c minus a plus, okay, it is minus a minus b. Okay, so a minus b minus c plus c. So what do we have? 1 divided by y power a plus b. Option number A. Sorry, not A because it is in numerator. We have option number D. Option number D. Question number 15. The true option. You have to check. So, x power 2 by 3 I have already taught you. It is the cube root of the square of x. Right? So, cube root of the square of x. Option number A. 16th. The simplified value of, let us simplify. 16 and 8 comes in the table of 2. Okay. Or maybe you can just directly multiply the constants directly over here. 16 into 8. Sorry, it is, I'm so sorry. It is 8 power minus 1. So it is 16 divided by 8. Okay. Into x minus 3 plus 3 into y raised to 2 minus 2. So this is 0, which is equals to 1. And this is plus 3. Okay, so this is plus 3 and minus 3 again 0, which is equals to 1. And this is 2. So only option number C. Okay. 17. The value of cube root of 8 and 27 is 2 and 3. So it is given in minus. So it has to be 1 divided by whole divided by 2 is to 3, which is equals to 3 by 2 into fifth root of 32 and 243 is again 2 by 3. Correct? It is again 2 by 3, but it is in minus, hence 1 divided by 2 by 3. So simplify it as 3 by 2 into 3 by 2, which is equals to 9 by 4. Option number A. Be careful with the minus sign. Okay. Next, question number 18. Question number 18. Again, be careful.